Hello, my name is Alex Alexander. I'm a current cybersecurity fellow at NYU Tandon, and the title of my paper today is Botnet Detection Using Big Data Tools. The agenda for today is I will go through the introduction, I will talk a little bit about the related work, I will move to my motivating example, I will go through an example of the application by modeling it, also have a worked example, and then conclusions and future work. So, what is botnet detection using big data tools? The idea behind it is that we have a lot of security issues surrounding botnets. So, there are different types of botnet attacks. We have DDSs, where you have multiple computers that are trying to attack a website and basically bring it down. And so some of the first issues date back to 2011. And the hardest part is how do you identify botnet traffic from normal traffic? And so if you can better identify what is coming from a botnet, you can then faster block traffic coming from those types of sources. And with that, you can block them and then allow traffic to be flowing for like your regular users that are not trying to do anything malicious. So early on, companies were hesitant to share information due to the fact that a lot of this stuff does have proprietary information that could be used back to them, or the customer information could be released, and that was something that a lot of companies didn't want. Fast forward a couple years to today, we really don't have so much of an issue of lack of data. We have a lot more data to be accessed, but it's still pretty difficult to build detection systems around this. To analyze that type of data, you have to really set up pretty complicated environments to do it effectively. And so the idea behind this project is we want to use some of the big data components and tools, but not have to go through and build out a whole clustered environment to do so. So we would like to build out a simple botnet detection program that really is able to detect botnets with the same accuracy of something of a larger scale application. So there were a couple of different papers that I looked at, and so one paper really gave me the overview from the example I gave in 2011 of where the field was, where there wasn't a whole lot of information available, and we didn't have the big data tools that we have today. Some research used synthetic traces and Java programs to analyze the data. Other researchers used Hadoop and Hive, which is similar to what I'm doing and what I kind of modeled my application after to be able to analyze the data. Moving further along to our modeling example. So in one of the papers, the idea was to build out a Hadoop and Hive clustered environment using multiple servers. And from that point, they used data from one source, and as well as they built their own data over time. So it took them about 4 months to be able to build enough data to be able to import into their Hadoop Hive environment and then train the random forest algorithm to be able to identify botnet traffic from normal traffic. However, I'm looking at it from the point of view that what if someone doesn't have 4 months to model this data? What if somebody has a small sample size and they want to be able to start quickly identifying botnet traffic for whatever business case or use case that that person has? So I took something similar to what those folks did, and I was able to build something that was a lot simpler. It used R and RStudio, which is RStudio is the kind of the GUI, and R is a programming language. And I created a faster way to be able to import the data and use the random forest algorithm to be able to detect if we are getting botnet traffic or not. And so the way that this happened was I had a data set that I got online and I uploaded it into Wireshark. So what Wireshark is, it allows you to be able to read a PCAP file, which is the type of file that you get network traffic in, and you are able to break it down into nice columns and rows. And so once you have that data in Wireshark, you are then able to export that data into a CSV. The reason you need that CSV is to be able to upload it into the RStudio, but also to update it into databases, SQL servers, Oracle databases, even Hive schemas. You kind of want to use a CSV file because it's just kind of a standard way to upload data into these type of database, is to be able to SQL and stuff like that. So that being said, I uploaded the CSV into RStudio, and from that point, we were able to actually get an idea of what the data looked like, title it, do a couple of checks on the data just to make sure that everything looked fine. And this data had a mixture of malicious, meaning botnet traffic, as well as just normal traffic as well. And so from that point, you run a couple commands with the data to be able to train it on the random forest algorithm. And what the random forest algorithm it allows you to do is that it's a proven and well-tested algorithm to be able to identify patterns, identify trends, and things of that nature. So in our case, what we're training the random forest algorithm to identify is you wanted it to be able to identify botnet traffic. And so how do you do that? You have to be able to say, okay, this subset of information belongs to botnets, and this other set of information is what normal traffic would look like. And so the random forest algorithm takes what botnet traffic could look like, and it kind of extrapolates and says, okay, this traffic coming through here, this also looks like it belongs in a botnet category, and so we identify it as that. And then it looks like, okay, looks like normal traffic, we identify up to that. However, our sample size was really small compared to 4 months worth of data. We only had a couple days worth of data here. And so with that, it only got about a 75% accuracy. I believe the approach to train the algorithm was pretty accurate. Where I did not have enough information is, in order for these algorithms to be really accurate and really precise, they need to see a lot of different variations of the same kind of problem. And so what that means is they need to be able to see a lot of different types of botnet traffic to get good at identifying it. It's similar to any human being trying to learn something new. You don't just do it once or twice and you learn it. You kind of have to do something. You have to practice. And essentially practicing and training the algorithm, you need data to do that. And that was kind of an oversight on my end when I tried to do this the simpler way. The issue when you get to having these large data sets is you need somewhere to store it. And I think that's where the Hadoop and Hive approach comes into place, is that those platforms are really made to handle big data, which is high volume data that needs to be stored and then as well as analyzed very quickly. My approach, while it works, it's never going to be as accurate because it's never going to be able to contain and analyze that amount of data. And so that brings me to my conclusion. While I think I was able to accomplish my goal of building a simpler application that identified botnet traffic, it was not nearly as accurate as something with a Hadoop Hive cluster that had 4 months worth of data. So I think this just goes to show that you really need large amounts of data sets and places to store it and analyze it to really be able to get accurate botnet detection. And the only way to do that really is to take your time and really do this the proper way. And so my lessons learned is sometimes you really can't do these things too quickly. You have to be able to take your time, build the data set, build a clustered environment to store all of this data, and then analyze it. 75% of botnet detection, while good, is never going to be good enough for a enterprise level system or application. So that is the end of my project. Thank you very much.